The name of the project is Analysis and Detailed Design of Multi-Storey Building. The students are Anudeep M, Sandeep M, Muni Sai Dheeraj. This is the abstract. The performance of a multi-story framed building during sturdy earthquake motions depend on the distribution of mass, stiffness, and strength in both the horizontal and vertical planes of the building. In multi-storied framed buildings, smash up from the earthquake, ground motion generally initiates at locations of structural weaknesses present in the lateral load resisting frames. In some cases, these weaknesses may be produced by discontinuities in stiffness, strength, or mass between adjoining stories. Such discontinuities between stories are often allied with sudden variation in the frame geometry along the height. A common type of discontinuity is vertical geometrical irregularity arising from the rapid drop of the height. This work shows the performance and behavior of regular and vertical geometric irregular RCC framed structure under seismic motion. 5 types of building geometry are taken in this project: 1 regular frame and 4 irregular frame. A comparative study is made between all these buildings configuration, height-wise and bay-wise. All the building frames are modeled and analyzed in software StatPro. Various seismic responses like shear force, building moment, story drift, story displacement, etc. are obtained. The seismic analysis is done according to IS 1893-2002 Part 1. Seismic zone 4 and medium soil strata are taken for all the cases. The change in the different seismic response is observed along the different height. Introduction. Splendor is one of the site where Appasamy Real Estates is constructing residential building which is located at Semancheri, OMR, Chennai. Objectives of this project are to analyze and design a multi-story residential building that provides a greater floor area while covering lesser land area, to design all the components of the building taking into consideration self-weight, live load, wind load and other factors. This is the methodology. The methodology is as follows: drawing of a plan, load calculations, analysis of the building, design of the building, results and discussions, and finally conclusion. This is the plan of the structure, which is of a G+5 residential building. This is the elevation of the G+5 building. These are the building specifications, which include the specifications of a column, beam, slabs, parapet wall, live load, flow load, grade of concrete, grade of steel, number of story, total height, height of ground level, height of floor to floor. This is the wind load calculation that we have done. The wind load calculation is based on IS 875 Part 3 1987. This has been calculated for G+5 residential building located in Kandanjavadi, OMR, Chennai. So these are the 3 factors, which is K1, the probability factor, K2, terrain, height, size, structure size factor, and K3 is topography factor. Therefore, after calculating, we found that the design wind load is 14.02 kilonewton. Next, we come to the analysis. These are the live loads acting. The primary loads are divided into live loads and dead loads. Dead loads. Dead loads are those loads which are considered to act permanently. They are dead, stationary, or unable to be removed. The self-weight of the structural members normally provides the largest portion of the dead load of a building. The figure represents the STAD Pro analysis of a dead load. Live load. Live loads, referred to as probabilistic loads or imposed loads, are temporary, of short duration, or moving. These dynamic loads may involve considerations such as impact, momentum, vibration, slosh dynamics of fluids, fatigue, etc. The image represented here is of a live load in a StatPro. Wind load. Wind load is the relative motion of air to the surface of the earth. Wind speed in atmospheric boundary layer increases with height from 0 at ground level to maximum at gradient height. A slight change in the wind direction within the height is neglected. The mentioned figure belongs to the wind load, which is represented in the StatPro analysis program. Next is the design of slab. We have designed the slab manually. Thus, here we can find that the design of slab is safe. Next is followed by the design of beam. Here it is the given data. Thus, from this, we can adopt nominal shear reinforcement using 8 mm diameter 2 leg stirrups at spacing of 300 mm center to center, followed by the design of column. These are the data. Later, we come to the results and discussions of the stat design. The given figure describes about the concrete design of beam number 86. This is the deflection result of beam number 86. This is the shear results of beam number 86. Conclusion. Planning, analysis and design of a G+5 multi-story residential building was done. All the structural components were designed manually and detailed using AutoCAD. The analysis and design were done according to standard specifications using StatPro for static loads. The dimensions of structural members are specified and loads such as dead load, live load and wind load are applied. Deflection and shear tests are checked for beams, columns and slab. The tests provide to be safe. Both theoretical and practical work has been done. This project is mainly concentrated with the analysis and design of multi-story residential building with possible cases of the loadings using StatPro. Meeting the design challenges are described in conceptual way. We may also check the deflection of various members under the given loading combination. Further, in case of rectification, it is simple to change the values at place where error occurred and the obtained results are generated in the output. Very less space is required for the storage of the data. StatPro advanced software provides us a fast, efficient, easy to use and accurate platform for analyzing and designing the structures. Work at internship. The work at internship has been done in the Kandanjavadi site. This is regarding the pile work. The type of pile used in this site is driven cast in situ pile. Followed by is the procedure. Here, three figures are given. The first figure belongs to the rig machine, which is a pile driving equipment. Second is a trimmy pipe, and third is a rig installing casing pipe. Tests. The tests have been done in the site. There are two tests. The first one is the compressive strength test of concrete cubes. The second one is lateral force displacement test. The two figures given here belong to these tests. The first one is a compressive strength testing machine, and the second test is hydraulic jack fixed to the piles. These are the observations of the test. These are the results after 7 days. These are the results after 28 days. Lateral force displacement test. It's a wind load test. This test is done to determine wind load capacity of the building. It is followed by the procedure. In the figure is given the hydraulic jack with movable lever. Here you can notice the hydraulic jack fixed to the piles. Bar bending schedule. Bar bending schedule is a list of reinforcement bars for a given reinforced concrete work item and is presented in tabular form for easy visual reference. These are the bar bending schedules for 2 grids that has been done by the students themselves for the entire slab. Shuttering work. Shuttering is measured in surface area and in SI units it is in square meter. The other way it is shuttering area and it can be calculated by measuring the area of contact of the shuttering surface with the concrete surface. Here are the picture which relates to the shuttering work calculation done by the students during the internship. The third is the block work calculation. Concrete blocks are an affordable building material that can be used for many construction projects and are suited very well for construction walls for foundation or utility buildings. This is the blockwork calculation which has been done in the Excel sheet by the students during the internship work. Thank you.